Okay, so I'm going to teach you about scientific notation today and a little bit of significant figures towards the end. So there are several rules about scientific notation. One of them is that we can begin by, so take out your left hand and imagine that it is filled with positive exponents and large numbers. Then take out your right hand and imagine that it's filled with negative exponents and small numbers. This is going to be used all throughout the scientific notation. And what I'm talking about here is that let's imagine for the left, going left with large numbers, you are, imagine that you have 500 and 650. So what are you going to do with 500? You are essentially going to take the 500 and you place the decimal where it naturally lays in the number 500. The decimal would stop right here. So you take that decimal and you go left however many times it takes to stop before the non-zero digit, which in this case is 5. And I'm going to show you more examples of this. So our number here would equal 5. 5.0 is 5. And that was 2 places that we created our loops. These are the loops that we have to create to count however many places the exponent is going to have, what number the exponent is going to be. So another example would be 650. You place the decimal where it naturally lays, and you just keep moving it until you get to the last, right before the last non-zero digit. But how do you write this? You are going to write down all of the non-zero digits and the decimal where you placed it. So you're going to write down 6.5. So 6.5, and where there's only one non-zero digit, you're going to place something like 5. Um, but you only move depending on what that exponent is, or actually, sorry, until you get to the non-zero digit, the last one, right before the last one. So on here, on 0.005, you are going to move again. This is a small number, so you are going to move right. You are going to, so this here, if you are going to be moving right, you are going to go until you go right before the last non-zero digit. Again, here on 0.008, you are going to move 2 times or however many times until you go right before the 8. And it doesn't matter whether the non-zero digits are on the left or the right. Usually they're going to be on the right for the decimals and the small numbers, and on the left for large numbers. But you have to stop before the last one. And in this case, the last digit is on the right again, and on for these, the digits are on the left. So again, what would 0.058 be? you would stop before the last non-zero digit, which is 8, and you would write both of the non-zero digits down and the decimal, and it would be 5.8. So writing this a number like 500, you have moved it 2 times, so you are going to put down your 10, and you are going to, that is the 10 that is the base that stays in scientific notation, and you are going to put the 2, you are going to put 2 in the exponent, because 2 is however many times you moved on the 500. And then you just bring down the 5, which was converted from the 500 by moving the decimal places, and you get 5 times 10 to the second. That's the scientific notation. So essentially, conversion of a number and how many decimal places. So what you're going to do is, again, if you have if you like going from this scientific notation back to the number is going to be, you're going to bring down the 5, and you're going to evaluate the 10 to the second. So 10 to the second, which from algebra you know is 10 times 10 twice. So you take that 10 times 10 and you equal it to 100, and then you just do 5 times 100 equals the answer of 500. And here is again an example of a negative exponent and how you are supposed to calculate that in your calculator. So you bring down the 5, you bring down the number on the left of the scientific notation, and then you create a positive fraction like in algebra. So you take the 10 to the negative 1, and you convert that to 1 over 10 to the 1. 10 to the 1 is just 10, so it's essentially 1 to the 1 over 10. And if you put 1 over 10 into the calculator, you get 0.1. So 5, which you brought down, 5 times 0.1 is 0.5. And that's how you get your answer. So moving on. So the evaluating rule, which I'll talk about further. The evaluating rule is, you can also do it this way. You can put the 10 down, which will always remain 10. Put the 10 down, and then again, if you remember your rules, which is positive, if it's a positive exponent, move left, and if it's a negative exponent, go right. So what you're essentially going to do is you're going to take the natural position of the decimal, which lies here on 10, and because it is a positive exponent, 2, of 2, you are going to go left. So you're going to move left 2 spots, and you're going to stop right there, which is going to lead for the answer to be 0.1. So you have essentially evaluated your 10 to the second correctly this way. So if you want to evaluate this further, we have the 5 times 10 to the second. The 10 to the second we have evaluated to be 0.1, and we have a 5, which we bring down. So we have 5 times -1, 0.1 equaling 0.5. So that's how you can evaluate the entire scientific notation. Again, if you have 5 times 10 to the negative second, what you can do with the negative exponent, for example, is the rule is negative exponent go right. If you have a negative exponent, go right. So we are going to start where the decimal naturally lays on 10, and we are going to go right however many times the exponent says. So the exponent is 2, so we move to the right 2 times. So we end up with 1,000. So we bring down the 5, which is the left number, to the scientific notation, and we bring down the 5 and we just multiply that by 1,000, which gives us 5,000. So moving on, now we have multiplying exponents rule, which is you just simply add them. You add the exponents. If you're multiplying exponents, you just add them, but you keep the base the same. And only the same bases you can allow you to multiply the exponents, which is another rule from algebra. So you keep the 10 here, and all you do is if it's 10 to the first times 10 to the sixth, you just take the 1 and 6 and add it, and you end up with 10 to the seventh. Again, here, if you have negative exponents, what do? You remember your rules from way back in pre-algebra, and you go to you just bring down the 10, and you so you bring down the 10, and you take the negative 2, and then you just subtract. Oh, sorry, add. You always add them. So negative 2 plus negative 5. I guess I did that wrong here, but let me redo this. Okay, so so when we are going to multiply our tens with our multiplying exponents, sorry, we're going to bring down the 10 because that base is going to stay the same, and then we essentially just add negative 2 and negative 5. So if we have our positive and our negative, we are going to end up with negative. So we have negative 2 minus 5. So negative 2 minus 5 equals negative 7. So we end up with 10 to the negative 7, which is directly, sorry. So our next thing is going to be so this looks a little bit confusing, but it is again just the algebra rules and using a calculator or just mental math to evaluate a a base, an exponent of the scientific notation. So what we are going to do is take, let's say we have 10 times 10 to the negative 1. We are just going to use our algebra rules here, and we are going to turn this 10 to the negative 1 into a positive fraction. So we have 1 over 10, 1 over 10 to the 1. And 10 to the 1 is just 10. So we have 1 over 10. And 1 over 10, whether you do mental math or use a calculator, you can evaluate this and to get 0.1. 0.1 times, this should be a 10 here, but 0.1 times 10, we put that into our calculator, should equal 1. And that's how you get your answer evaluating, and you just bring this part down, evaluating your scientific notation. You just bring this part down, this number to the left of the scientific notation, and you just multiply to what you just evaluated this to be, 10 to the negative 1. Okay, so next we have dividing scientific notation, dividing with scientific notation. So we are going to be dividing the numbers and subtracting the exponents. That's the two rules that we have to follow here. So if we have a 5 times, and let me rewrite this. If we have a 5 times this, 5 times 10 to the negative second as our scientific notation, then we are going to take, and then we also are going to take 1 times 10 to the negative 5, which we are dividing by. So essentially what we're going to do, these are the numbers here, right? These are the numbers to the left of the scientific notation. We are just going to take these numbers and divide top to bottom. So 5 divided by 1 equals 5. And we bring down the times symbol, and then we're going to subtract negative 3 from negative 5. So negative 3 minus negative 5, so minus here, whoops, okay, that's messy, let's go to this one. Minus becomes plus, as you can see here. And negative 3 plus 5 gives us 2. So then we have, we just write our 5 down that we got from this answer here by dividing that. And then we just, what we subtracted, the exponents that we subtracted from each other, top from bottom, we just are going to bring that down, rewrite it. So we have 5 times 10 to the 2. And you can evaluate that further if you wish, using the steps that I showed you before. Okay, so a couple more, and this is, I'm going to write this out. This is the rule of how to write positive exponents, write scientific notation, positive exponents quickly. So what you're going to do is basically you are going to bring down the 2 that you see right here. You're going to bring that down. And so you're going to bring down your number, and then you're going to take your exponent, which happens to be 4 here, and you're going to write 4 zeros. You're going to write however many however many zeros that the exponent says. So I wrote down my 4 zeros, and my answer becomes 20,000. That's how I do it quickly. Okay, next we have our last page, which is significant figures. And let me just write it here. Significant figures. Okay, so what you're gonna do is if you have a small number like 0.0082, you are only going to keep the non-zero digits. So the 8 and the 2, and the reason you're gonna do that, the 8 and the 2 are the 2 significant figures. And because they are non-zero digits, but the main thing is here that you have the decimal starting with zeros. If it starts with a 0, you are going to disregard the zeros, so you don't count them because it has started with a 0. So let me just write that down right here. Starting with zeros. Starting with zeros makes it not count. Makes the zeros not count. So in this example below here, 0.0005, 5 is the only significant figure. So there's only one significant figure, and the reason is because it starts with zeros. However many zeros that the decimal starts with, the decimal begins with, that's you have to ignore those. You cannot count them. So number like 350. So a number like 350, you just see where the decimal naturally begins, which is a place such as here, where it naturally is. And if the 0 is before the decimal, you can count it. If it is before the decimal, you can count it. And so 350, a number like 350 would have 3 significant figures. So we are only counting non-zero digits again, and we're not counting the zeros that come after the decimal, beginning the number. Okay. So again, we have finally trailing zeros. Trailing zeros can be counted if they come before a decimal and after a decimal be if there is a number before the decimal, then you can count. If you have a non-zero digit in the left part of the decimal, then you can count all of the zeros. It simply can't begin with a zero, which means that it doesn't have any zeros out here. If it had a zero here, then you still cannot count it because it begins with zeros. But let's say we have a 1 and then a point, a 1 and a 0 and decimal 005. Then we are going to count the entire thing. Why? Because it begins with a non-zero digit. And let me just write that in. Begins with a non-zero digit, zeros count. So if you have a and that's exactly what I'm talking about here. If you have a non-zero digit such as 1 and then a 0 and then decimal and then more zeros and a more non-zero digits, even if it would all count. So there's 5 significant figures. Even if it had something like this, would still count because it is not a number that has zero, like it's not beginning with zeros. It has a non-zero digit here. Begins with non-zero digit, all zeros valid. Okay. So finally, the most important thing, or not even most important, just really just important. 37,000 is a number that is essentially made with a comma. So that comma, if you have zeros after a comma, they don't count. Only the 37 counts. So you only have 2 significant figures here. Let me write that in. 2 significant figures for this. The comma and the zeros don't count here.